I wanted to make a series of videos that record my interest and my efforts to model Coventry railway station in the West Midlands, using my Hornby Dublo toy trains from the 1950s and the 1960s. I thought maybe there might be some other people that are interested in following my journey, but mainly I'm also really keen to know if people have ideas and thoughts that will help me improve my project. Now, this particular video is about my initial experiments with creating an automatic slow down and stop system for a DC controlled toy train. Of course, if you have a fancy DCC system, there are a lot more elaborate ways of achieving this and other effects. But because I'm using the Hornby Dublo, I wanted to keep it as relatively simple as possible, not quite analog, but as close to it as I can. My particular interest in developing a slow down and stop system comes about because of the track layout at Coventry Station. Now, it's essentially a mainline track which runs from Birmingham to the west, so in this image to the left-hand side, through to London on the right-hand side of this map out to the east, and with two branch line junctions, but both of which are double track. To Nuneaton to the north, the junction being on the west side, and down to Leamington on the east side, the track running south. So this creates two major junctions. So if we now transpose that focal point for the layout into my broader current idea for a scheme, I think it would be nice to have the option to have trains running automatically and continuously. So if trains could come from Birmingham, from the west, through Coventry Station and head out towards London, I'm thinking of building essentially a reversing loop from what would be the up line to London, so they can follow the loop and then come back, being seen on the down line heading back towards Birmingham. They can go back through Coventry, out towards Birmingham, in theory, stop there, do the necessary exchanges, and head back. But of course, in reality, they're just on the loop, and they will be seen coming back on the down line from Birmingham into Coventry and off to London, and so on and so forth. Then I would like, I think, maybe to do a similar thing for the axis of tracks, north-south. So to be able to see trains, probably more likely to be suburban trains or intersuburban trains or goods trains, because Coventry was surrounded by a number of industries, which maybe I'll talk about another time. But coming from the Nuneaton direction into Coventry, through the station, and then heading south towards Leamington on that branch line, going around the reversing loop, being seen coming back. Maybe without their cargoes, we could have a think about how that could potentially be automated in some clever way, maybe. But to come back through Coventry and then to rejoin the rugby line, head there, do the loop, and come back, and so on and so forth. So I'm envisaging a possibility where we have maybe at the minimum two trains doing continuous loops in a sort of, I guess, interlocking two series of eights arrangements. And this, of course, creates the possibility for major crash scenarios at the junctions at the west and eastern throw of Coventry Station. So what I wanted to do was to develop an automatic slow down and stop system along the lines of a prototypical block system. That means that the trains would pause if it was necessary, ideally at a red light or a stop or danger signal. If another train was in the station passing through, before then, once that the sort of the danger had cleared, the train could then proceed on its journey. And thinking about the sort of the automatic route setting, etc. And then if I could achieve this as a basic standard, I could then think about how extra play could be added in around the use of the many sidings and other aspects of engine sheds and things like that, coaching sidings around Coventry Station, to make some really interesting possibilities. And of course, preserving the opportunity to take control of the mainline trains and the branch line trains going in and out of the station as well. But it seemed to me that I absolutely needed some way of automatically stopping the trains from crashing into one another. So I have been doing some experiments. So I have built a little test track of the concept that I have developed. It has to be said, based on some really useful discussions and other forms of information I found kicking around the internet, and also using ChatGPT for some of the more technical aspects. So I don't know how much other people who are interested in model railways also use AI and as me, ChatGPT, but I found it like a really good resource because obviously it can draw from wider discussion and knowledge on the internet and use its language models to generate very quick answers to potentially quite technical questions. So that, a little citation to that. This is not my own mathematics, but what I've got here is so a curved rail where the power feed comes in. So that's standard voltage from the 12 volt track feed. Then what I've got is, so this red wire coming off to my first Wago joint. So this is something else that I found really useful. Wago joints, obviously, for standard domestic electricals, really expensive way of doing it for model railways, or probably more expensive than soldering things together, but a really great way of attaching my wires and my diodes together in a temporary way, and also a flexible way to test different arrangements. So my power feed coming in, and then I've got so I've got a back and forth arrangement here. So that's 1, 2, so 3 diodes, which I understand restrict the electrical flow to one direction, but also each additional diode steps down the voltage by some degree. So I've got 3, and then I've got a feed off to my first standard curve, and then from there the circuit continues through an additional 1, 2, 3, 4, yeah, and then a feed cable off to my second full curve, and then the final half curve there there's no electrical feed. And what I've done is I have removed the connections in the live rail of the third rail system between each of these. So without the wires, each of these rails would be dead. And I did that by just unclipping the folded tin plate from the back and removing the connection. Let's see if I can find it. So what I did is use a screwdriver to just lift up the two little tin plate nibs. So then the joint plate can be removed, thus kind of killing the power to all the rails, but maintaining the return feed through the 2 outside rails. So that is the setup, and I have tested this, and then I've measured each section of track with my voltmeter. So what I have come to learn, so the full power is about 12.4 volts. So the first rail, which dog's not happy, the first rail, which has the 3 diodes, brings it down to 11.1. The second rail, which then goes through the full 7 diodes, brings it down to 10 volts, and then the last rail is dead, so it's obviously 0 volts. The diodes I've used are these, and again, this was all credit to ChatGPT. I asked it how I might achieve the effect that I wanted, and it suggested this particular standard of diode. So I've got some of these on Amazon, and the main thing is to show the effect, which I'm really pleased with. So what I'm going to do is I'm just going to max out my controller. The train will run at full speed for the first rail, and then it will slowly, relatively speaking, slow down under the 2 voltage steps, and then obviously when it hits the last rail it will come to a dead stop. So let's just make sure I give this maximum potential. So here we go. There we go, and the controller is still at maximum. So that is a fairly smooth slow down and stop as far as I am concerned. Now, I can, and one could, have more rails with more slow steps to achieve a slower reduction in the speed. But I think potentially you don't want your feed to the last rail to be so low that maybe it's going to stop preemptively. That wouldn't be terrible, I suppose. But there's a certain balance to be struck, and obviously with space. And I am trying to hit a balance between something that can be played with and something that's relatively realistic. Obviously the stopping speed is not realistic, but I think it achieves the effect that I want. And this is mainly a fail-safe, so I can have my kind of mainline trains running round in a loop of some type, probably definitely through back and forth through my main station. But if I want to then engage in some like workings with branch lines and sidings and movements within the station, I basically want a fail-safe to make sure that the sort of express trains on the main line can continue to run without me needing to pay them attention, but they will stop at what will be, so this is my next step, is to set up so a red light, a red and green and amber 3-aspect light, and then a preceding traffic light that will obviously be at warning when this is at red, and so it would combine the lights with the slowing down. So I can set the lights to red, and then any kind of trains coming towards the station will have to stop, so we don't get any crash situations. Now, the only slight, I guess, disadvantage with this system, it's not super sophisticated, but because the diodes restrict the flow of energy, and the way that the Dublo train works is to go in reverse, it reverses the polarity. So in this case, we've got the energy coming in through the third rail, through the motor, and then back out through the 2 outer rails. This happens to be, this locomotive is going in reverse. If I switch it, the polarity will reverse from the transformer, and will be coming out through the 2 outside rails, through the motor, and then return to the centre rail. But then the centre rail is connected into this circuit with the one-way diodes. So if I obviously, so this rail is dead, so put that into so the forward direction. Let's kill it for now. So bring that from the dead rail onto the electric rail, or one of the electrified rails, through the diode, and then max out again. So circuit's flowing fine through the transformer, but the energy can't go back through the diode, so it stops in this arrangement. You can't reverse against the route. So to some extent this is fine because I'm going to have up and down lines, but for kind of workings within a station and doing other things, you may this isn't an ideal arrangement. But my plan is that there will be a switch, so I can either feed the rails in this arrangement when the light is red, or when the switch is switched, the light will go green, and I will essentially, this circuit will be disconnected, and it'll have to be 3 independent power flows will return to the 3 rails, will be switched back to the 3 rails, which will give it normal power. So they'll be independently powered outside the circuit, but there'll still be energy. And this means because there'll be no diodes in that circuit, then the energy can flow in both directions. So as long as the traffic light is green, if you need to, you can back or reverse or go forward, whichever way, in the opposite direction down the line that's carrying this system. So let's do another test just for fun. So again, so reverse, max power, nice gentle slowdown and stop, relatively gentle slowdown and stop. So far, so good. feeling pretty pleased with that.